For this question, we're going to look at the limiting reagent and theoretical yield for this reaction. If 100 grams of sodium and 100 grams of iron 3 oxide react, we're going to then determine the mass of the iron that can be made. First, we're going to need to write out the equation and balance it. We have sodium, so Na, and it reacts with iron 3 oxide. We need to determine what the formula for iron 3 oxide is. For this, I'm going to write it down here, iron 3 oxide. We know our elements are going to be Fe and O. This 3 Roman numeral tells us that this is 3 plus. And then for the oxide, we need to go to our periodic table to determine the charge. We know this first column's +1, then +2, and +3, and we can go the other way. We have 0, -1, and -2. So our oxide is going to be -2. We can crisscross these charges where we do 3 over here and 2 over here to get our formula. We get Fe2O3. So we're going to write this up here. Fe2O3. And now we need to determine our products. For these products, we have sodium plus iron oxide. This is going to be a single replacement reaction. So I'm going to draw our arrow, and what we get is sodium oxide, which is Na2O plus Fe. I'm going to move this slightly over. And the reason it's Na2O is because, again, sodium's +1 and our oxide is going to be -2. So we need 2 sodiums to make up for that O -2. Okay, we're going to balance this now. On each side, we have sodium, iron, and oxygen. Sodium, iron, and oxygen. Now we have 1 sodium and 2 sodiums. We have 2 iron and 1 iron, 3 oxygen and 1 oxygen. So let's balance our oxygens first. We're going to put a 3 here, and that's going to give us 6 sodiums and 3 oxygens. This balances our oxygens. And then we can balance our sodium, so we can put a 6 here. And then balance our iron by putting a 2 here. This balances everything. And our balanced reaction will be 6 sodiums plus our iron oxide goes to 3 Na2O, or our sodium oxide, plus 2 iron. Now what we can do is we can determine what the limiting reagent is. So we'll start with our sodium. We have 100 grams of sodium. And we're going to convert this into moles. So in this case, we know from our periodic table that sodium is 22.99 grams per mole. So we're going to put 22.99 grams sodium and 1 mole sodium. If we were to stop right now, we would be in moles of sodium, but we need to get all the way to grams of iron. So our next thing is looking at the mole ratios. From our balanced reaction, we see that for every 6 moles of sodium, we produce 2 moles of iron. So that's the ratio we are going to use. For every 6 moles of sodium, we can produce 2 moles of iron. So 6 moles of sodium produces 2 moles of iron. Right now we're in moles of iron. We need to do one more step. We need to get this into grams of iron. And we're going to use from the periodic table the 55.845 grams of iron over 1 mole of iron. So then we can calculate this all out, and the way that we do that is we're going to take our 100 times 1 times 2 times 55.845, and then we divide it by our 22.990 and divide it by 6. What we get is 80 point, and we'll do 3 significant figures. So this will actually be 81.0 because it's 80.96. So we get 81.0 grams of iron. Now, this is for what our 100 grams of sodium can produce. We also need to do the grams of iron oxide, because we're looking for which one's the limiting reagent. So we're going to do our 100 grams of Fe2O3. Same thing, but now we need to use our mass of iron oxide. In this case, iron oxide Fe2O3, that mass is 159.69 grams, 1 mole. And then we use our mole ratio again. So we're going to look, every 1 mole of iron oxide, we can get 2 moles of iron. Because there's no coefficient on that iron oxide, it's an implied 1. So we get 1 mole and 2 moles iron. So we're looking at those coefficients. Okay, if we stopped right now, we'd be in moles of iron, but we need to go one step further and get it into grams of iron. So we get 55.845 grams of iron. And so this is just the molar mass of iron. So we're going to do this calculation for iron oxide. So we do 100 times 1 times 2 times 55.845 divided by 159.69. And what we get is, we're going to do 3 significant figures, so 69.9 grams of iron. Now in this case, this tells us that our iron oxide is our limiting reagent. The reason for this, so limiting reactant or limiting reagent, the reason that this one is the limiting reactant or reagent is because it can only produce 69.9 grams of iron, whereas the 100 grams of sodium, if it was reacted fully, could produce 81.0 grams of iron. So iron oxide is our limiting reactant, and the mass of iron that can be made is 69.9 grams of iron.